In this video, we solve a chemistry problems involving the calculation of the mole fraction of potassium iodide in a 20% weight by volume aqueous solution with a density of 1.202 gram per milliliter. We talk through step by step to determine the mass of potassium iodide and water in the solution, and we also calculate the mole of potassium iodide in water, and then find the mole fraction of potassium iodide. This example demonstrates how to apply concept of solution concentration, molar mass and mole fraction in a real-world scenario. If you are looking to enhance your understanding of solution chemistry and mole fraction calculation, this video is for you. Let's assume you are given this kind of problem which says you should calculate the mole fraction of potassium iodide if the density of 20% weight by volume aqueous. In aqueous, potassium iodide solution has a density of 1.202 gram per milliliter. So how can we solve this problem? First thing we need to do in order to calculate the mole fraction of potassium iodide in the solution, we first need to determine the mass of potassium iodide and the mass of water in the solution. Let's say we are given 20% weight by volume. That means if we are given 20% weight by volume, this simply means that there is 20 grams of potassium iodide in 100 milliliter of the solution. So the mass of the potassium iodide in the solution is simply going to be 20% of milliliter, which is going to be 20 grams. In this case, we're going to have 20% of milliliter is simply going to be 20 grams. So the second thing we need to do is to know the mass of water in the solution. In order to calculate the mass of water in the solution, this is simply going to be 20%. Mass of water in the solution is simply going to be 100 milliliter minus 20 milliliter. This is simply going to be 80 milliliter. Or you can set 100 milliliter minus 20 milliliter. This is simply going to be 80 grams. Next thing we need to do is to calculate the moles of potassium iodide and water using its respective molar mass. So the molar mass of potassium iodide is approximately 166 gram per mole. So we need to know the molar mass, or let's put it this way. We need to know the molar mass of the potassium iodide, and we also need to know the molar mass of water. We said the molar mass of potassium iodide is approximately 166 grams per mole, and the molar mass of water is approximately 18 grams per mole. So the next thing we need to do is to find the mole of potassium iodide, and we also find the moles of water. So the moles of potassium iodide, which is Ki, is simply going to be the mass of the potassium iodide, and we are going to divide that by the molar mass of potassium iodide, which is molar mass of potassium iodide. Therefore, this is simply going to be what is the mass of potassium iodide? We are given the mass of potassium iodide. The mass of potassium iodide divided by molar mass of potassium iodide. So the moles is simply going to be 20 grams, which is 20 grams. That's what we are given here. It's going to be 20 grams divided by 166 grams per mole. In this case, grams will cancel out. We're going to have the moles of potassium iodide to be 20 divided by 166 mole. So the mole of what potassium iodide is simply going to be, if you divide both sides, this is simply going to be 12.1205 moles. Next thing we need to do is to find the moles of water. This is the moles of potassium iodide. The moles of H2O, which is for water, is the same thing. We are going to apply the same techniques, which is the mass of H2O divided by the molar mass of H2O. In this case, the mass of H2O is given to be 80 grams, which is simply going to be 80 grams divided by 18 grams per mole. Grams will cancel out. If you divide both sides, our moles of H2O is simply going to be 4.444 in moles. So in this case, this is the moles of potassium iodide and this is the moles of water. Now, we can calculate the mole fraction of potassium iodide. How can we solve that problem? The mole fraction is being donated by Chi. The mole fraction of potassium iodide is simply going to be the moles. It's simply going to be the moles of potassium iodide. Then we are going to divide by the moles of potassium iodide. Moles of potassium iodide. We are going to plus that with what moles of the water, which is H2. In this case, this is simply going to be the moles of potassium iodide. We know to be what 0.1205 mole, which is simply going to be 0.1205. We are going to divide by 0.1205 plus 4.444. If you plus and divide everything, the mole fraction of what potassium iodide is simply going to be 0.0266, and this is it for this problem. So the mole fraction of potassium iodide is simply approximately 0.0266, and this is it for this problem. Thank you for watching.